All right, we're going to dive into a concept that, I'll be honest, sounds a little strange at first, but it might just completely change how we think about building software. It's called write-only code. So let's get right into it.
So let's just kick things off with a pretty wild question. What if most of the code that runs, well, everything, was written and then just executed without a single human ever looking at it? I mean, never. No skimming, no code reviews, nothing. Sounds crazy, right? But this is the future that many people think we are absolutely barreling towards.
And this idea, it has a name, write-only code. And it is exactly what it says on the tin. Now, this isn't about some sloppy code that nobody wants to read. We're talking about code being generated at such a massive scale that human review becomes, fundamentally impossible.
Now, you're probably thinking, okay, this sounds like science fiction, maybe decades away. But the thing is, this future, it's arriving a whole lot faster than most of us realize.
You see, AI writing code, that's not a new idea. We've had code generators for ages. But the real revolution here isn't in the writing. It's the total absence of human reading. And that's what's going to change absolutely everything for engineers.
So how is this even possible? Well, it turns out this is all part of a very familiar pattern in the world of software development. To really get where we're going, we first have to take a quick look back at how we got here. You can almost look at the entire history of software engineering as this constant cycle. We find one huge bottleneck that's slowing everything down, we innovate like crazy to get rid of it, and the very second we do, we slam right into a new bottleneck somewhere else.
And you can really see this pattern if you just look back at the last massive shift in our industry. I mean, it wasn't that long ago that servers were treated like pets, right? Each one was super precious, it had a name, you lovingly maintained it. The bottleneck was getting your hands on physical hardware. And then, boom, the cloud shows up. Suddenly, servers become cattle. They're just nameless, disposable things you can spin up or tear down with an API call. And just like that, the hardware bottleneck, gone.
So there's the cycle right there in action. Once the hardware problem was solved, the bottleneck immediately shifted to developer velocity. Basically, how fast can a human being turn an idea into working code? We've spent decades optimizing that, but now we've hit the next wall, the sheer speed of human review. And this is the crucial point. That final bottleneck, the one we've built our entire way of working around, it's about to break. The era where every single line of code has to be approved by human eyes it's coming to an end.
Right now, we think of AI as a copilot, an assistant. It makes us faster, sure, but a human still has to break down the problem, review the pull request, and give that final thumbs up. The fundamental process hasn't really changed because human review is still the ultimate gatekeeper.
But the game is changing fast. These new AI agents aren't just little helpers anymore. They can take a high-level goal, plan out all the steps, write the code, and even fix their own mistakes. They're starting to churn out software at a volume and a level of complexity that we can't keep up. There literally are not enough hours in the day for humans to read it all.
Okay, so if engineers aren't going to be spending their days writing and reviewing code line by line, what are they going to do? This is where the job completely evolves, from being a hands-on coder to more of a high-level systems architect. The job itself just transforms. Your role shifts from being an author to a systems designer. Instead of being a reviewer, you become a constraint writer. You're the one who defines the rules of the road for the AI. You stop focusing so much on the nitty-gritty implementation details and start managing the big, high-level trade-offs for the entire system. So, what does this new engineer actually focus on? Well, they shape the intent of the software, not the implementation. They obsess over things like stable interfaces and the core rules of the system, the invariants that can never, ever be broken. They define all the possible failure modes. They manage something called the slop radius, which is how far things are allowed to go wrong. And critically, they're the ones who decide which tiny fraction of code still needs a human to look at it. And look, this is more than just a change in your daily to-do list. It's a massive psychological shift in identity. That pride an engineer takes in their work, it moves away from the craftsmanship of a single perfect line of code to the elegance and the resilience of the overall system. The whole statement just changes from I write code to the much bigger, much broader I build software.
This all leads us to the biggest, most important question of all. If we're not reading the code, how on earth can we trust it? I mean, to run our businesses, our infrastructure, our lives, we are going to need a whole new set of rules for establishing trust.
Right. The need for correctness and accountability doesn't just disappear. If anything, it becomes even more critical. We just can't rely on the old ways of doing things anymore. We need new, automated ways, new primitives, to make sure our systems are doing exactly what we intended them to do. So one fascinating idea that's been proposed is a new metric called code reading coverage. It's kind of like test coverage, but instead it would track what percentage of your code in production has actually been seen by human eyes. But here's the twist. But here's the crazy part. The goal isn't to get that number to 100%. No, the goal for the best teams is going to be to drive this metric down, as close to zero as you can get. Think about that. Having a human actually read the code becomes a bad sign. It means your automated systems for building trust just aren't good enough yet. It completely flips our entire idea of safety on its head. So this new foundation of trust, it really rests on 3 pillars. First, accountability. A human is still on the hook for the outcome. Second is control. Engineers have to design systems that contain that slob radius to limit any potential damage. And third, tooling. World-class automation is what turns shipping unread code from a totally reckless act into a massive competitive advantage. You know, when you take a step back and really think about it, this future role isn't actually so different from today. The fundamental job of a software engineer was never really about just typing on a keyboard. It has always been about reducing risk in a world full of ambiguity and constraints. And in a world of write-only code, that core responsibility, it doesn't go away. In fact, it gets bigger. It becomes more important, more strategic. The engineer is basically promoted from the engine room to the bridge of the ship. And that leaves us with the central challenge for the entire next generation of software engineering. It's not a question of if this is going to happen, but how. We all get ready for it. How do we design the systems, build the tools, and create the culture to make sure that software stays correct, resilient, and accountable when it's operating at a scale that's way beyond human comprehension? That's the question we all need to start thinking about, starting today.